So I'm Dave Arterburn. I'm the director of the Rotorcraft Systems Engineering and Simulation Center at the University of Alabama in Huntsville, Alabama, and this is the Complex Systems Integration Lab. The Complex Systems Integration Lab was founded in 2015 based on a need for more complex systems that are being developed by the military and even our commercial partners. I ran a study of the airworthiness of complex systems that brought academia, industry, and government together, and we looked at the problem of how do you certify complex systems. And in that study, it became very apparent that there was a vacuum where organizations could work together to look at model-based systems engineering tools and work together to develop a common language or a common interface that would allow models to be shared across industry and government for the benefit of both. But there wasn't really a location where they could do that. And so that was the genesis of the lab. So I approached Dr. Ray Vaughn, the Vice President for Research at the University of Alabama in Huntsville, and explained the need of how our partners on Redstone Arsenal and even NASA Marshall Flight Center, Space Flight Center could use the lab to facilitate their use of model-based systems engineering tools that are evolving very rapidly now, but the organizational expertise of how to integrate those tools into acquisition processes and business processes isn't being done at the same rate. And so we needed a place to merge those two capabilities, and that is the Complex Systems Integration Lab. So the Complex Systems Integration Laboratory we've integrated a number of different model-based tools in the environment, and to date we've used that laboratory to work on model-based systems engineering for our own projects. So as we've developed different projects, like one of them is the Auxiliary Ground Power Unit for the Army, we used model-based systems engineering tools to design that product, especially the software and hardware integration, to get a streamlined approach for not only requirements, but to actually do testing and have it all done in one modeling environment. And so that lab facilitated that work and a very streamlined approach to the development of that software. We hope to expand the lab into a broader dialogue about organizational dynamics and not just the use of the tools. So right now we have two graduate research assistants that are in the lab, and the emeritus scholar, Dr. Dale Thomas, out of the Systems Engineering and Engineering Management Department at UAH, is in that lab, and he has started his own research and the research with those graduate research assistants to focus on how NASA could potentially use that model-based environment to do trade studies and link that model-based systems engineering tool with a real-time rocket model that they're using there's a physics-based model. So one of the problems with model-based systems engineering tools is you don't always link the model-based environment with these real-time tools that individual engineers and functional engineers are using. For example, computer-aided design that is prolific throughout all industries. That is probably well integrated with model-based systems engineering tools, but it's not necessarily linked to look at interfaces with the MATLAB environment or engineers that are working in physics-based tools so that they can all work together and you can do one analysis with all these tools working together to determine whether you're meeting requirements, whether your requirements are valid. And so why wait until you've built and spent a lot of money building items when you could go find out that the requirements aren't valid in the virtual space? And that's the intent of the lab. And so we've done a lot of work to get those tools integrated in the lab, and now we've started bringing students from various departments into that lab to work with our researchers that are electrical engineers, mechanical engineers, practicing designers, so that they can work with the students to look how we interface these tools and do it effectively.
My name is Keith Marshall. I'm a computer science major and an undergraduate, and I work here at Rotorcraft at the Von Braun Research Center. I started wanting to be a mechanical engineer because I like to invent things, but decided I preferred programming, so I switched. Right. My main project right now is ACPU, Air Ground Power Unit. What it does is you hook it up to a helicopter to pre-test it before flight. I think they test it daily, and the previous ACPU units are outdated. They're not really easy to use. So we're making a upgrade to it to touchscreen, interface with laptops, the whole works. It'll be much easier for the user to use. A lot of times I'll get an assignment from my supervisor, Philip Aldridge, who gives me a lot of tasks for the software of the AGPO unit. And I'll often learn things in the lab and then take the class later that I'm supposed to be learning from that class, but I've already learned it here. So it makes things a lot easier. What I like best about working here is learning new things and getting paid for it. I think any student that really wants to get into the field as quick as possible and get paid for it, they need to bring some skill before getting hired here. But once they do, they're set. They'll love working here. If you're a mechanical engineering student, you need to at least know how to CAD. We use Creo mostly, but we sign on people that know AutoCAD or Solid Edge. If you're a programmer, then you should probably know at least the basics. When they signed me on, I just knew basics of C++ and Java. I've learned a lot more since then.
So the commercialization aspect is very interesting because the interface to a lot of these tools requires a collaboration with the tool builder and then how the application is being applied. So we think that there's some opportunities for commercial companies to come in and help us look at the interfaces and how we can interface different tool sets so that depending on how you contracted, you don't have to change the way industry does business. You just have to be able to document the interface that you need to be able to read their tools into your model-based systems engineering environment, and that's one of the big challenges. And so I think there's opportunity for us to commercialize those interfaces and to look for opportunities where we have unique interfaces and develop tools like graphical user interface that make it easier for the systems engineer to do his work. The model-based systems engineering tools do well, but they're not always the most intuitive upfront designs. If you look at the way MATLAB and Simulink was developed over time, the original Simulink development tool was not very intuitive, but now it's become the industry standard and people really understand the interface because you can understand looking at the model, how it's built, and understand the connectivity, not just the control design, system design that's underneath. So that's what we're looking for in terms of developing better practices and then transitioning those to the community. And all that stuff will be done, if there's a commercial value to that, will be done through the university's Office of Commercialization and document the process and then share that with industry to move it forward. We're looking for students and faculty from all disciplines because this is really a multidisciplinary laboratory environment. But we're also interested in looking at acquisition professionals, business professionals, industry. We want to get government and industry working in the lab in a non-threatening environment to look at the contractual relationships between them before the government or industry tries to deliver a model that the government can't use, or the government requests a model be built that they can't really interface with or changes the way industry does business. They need to look at how they operate together, and the lab is a great environment. There's no capital investment by industry or government. The university's paid that capital investment. All we're asking is that they come and work in the lab together to make sure that what we're building and how we're building it is an enterprise solution that can benefit the acquisition community, industry as a whole, because even if we get industry interested and they develop these tools themselves, they have to eventually transfer those deliverables, and we want to get out of text-based deliverables and deliver the model so the full understanding of the physical system can be realized by the acquisition professionals and the airworthiness authorities that have to receive it and then ultimately sign off on the dotted line for it to fly. That has to get much better so that we don't make mistakes way late in production that ultimately derail programs because they're very expensive. I hope that this lab right now, we've built a good environment for us to start the collaboration, but I think once people get in the laboratory environment and they take an opportunity to experiment in there and look at what their organizational piece is I hope that the lab, our aspirations for the lab are that they move forward and grow to where that becomes an educational tool so that we can change the workforce on Redstone Arsenal and NASA Space Flight Center to teach them how to use these tools effectively so that we can build more affordable systems that have much better performance and much better capability. But until we get there, until we experiment a little bit in the organizational dynamics, it's really going to take a group of people to come together and understand the dynamic and then carry it onto the arsenal so that we can achieve that goal. And that's what we want to do here. So they can look at our website. It's rsesc.uah.edu. And there they can see things that are going on in the Complex Systems Integration Lab, as well as our vertical lift technology and our unmanned systems technology. And they can get my contact information there. And then from that point, we can get together and talk about the opportunity.